Okay, let's get back to this. We're on page 3 now. It says a 4.5 kilogram cart is traveling north towards the second car with a mass of 2.5 kilograms traveling south. So we're going to have a head-on collision here. So let's put the 4.5 is here. He's going north at 8. And this other cart, and it's 2.5, is going south at 3. So they're actually closing the gap between each other at 11 meters per second. Let's call this guy number 1, and this is going to be number 2. So we have to make sure that for the formulas that we have, V1 primed equals M1 minus M2. V1 has to equal, V2 has to equal 0. And then you also have this one here, V2 prime equals V1 plus V1 primed. Okay, so you just have to add them up. So let's get this. This only works if V2 is 0. So we have to make sure that this guy looks like 0. Right now he's negative 3 because this is positive and this one is negative. So if I add 3 to both of these numbers, this becomes 11 meters per second. This will be my V1. And if minus 3 and plus 3, then V2 will now be 0 if I add 3. So I have to adjust for this, and then these formulas will work. Okay, now it's fast, because now we can just find V1 primed will equal mass 1, which is 4.5, minus 2.5, over the total of the two masses, which is 4.5 plus 2.5, times the original velocity of 11. So let's do this. 4.5, 2.5 minus is 2 over 7 times 11. It's a messy number. Okay, that's how fast V1's going. V2 will be V1 plus V1 primed, which is 11 plus 3.14 is 14.14. Okay, that's the velocity of these two guys here. In my make-believe world where I adjusted the velocity, how do we adjust it backwards again? I have to undo what I did. So minus 3. Okay, so that's the answer for that one. Minus 3. Okay, that's your answers there. Might as well put a box around them. Okay, next question. They said, verify that the kinetic energy was conserved. Well, let's find the kinetic energy at the beginning. So velocity of the first cart plus, the kinetic energy of the first plus kinetic energy of the second one. Mass is 4.5. Initial velocity was 8. Plus 1/2. 4. No, the other one is 2.5. And its velocity was 3. So I got 4.5 times 8 squared. Divided by half is 144. And I got 2.5 times 1/2 times 9 is 11.25, which gives me a total of 155.25. With a whole bunch of extra units. But let's do after the fact. I'll call this one EK primed. Will be these two added together again. Don't use the velocities you adjusted though. Not the 11 and 0, not the minus 3.4. You have to use the actual ones. So go to these guys here, 0.14. So this will be 1/2, 4.5, 0.14 squared plus 1/2, 2.5, 11.14 squared. So 0.14 squared times 4.5 times 0.5. It's not much at all. And this one, 2.5 times 1/2. And then 11.14 squared times that is 155.124. When I add them up, we get 155.16. Okay, Within significant digits, we're fine. If we had left many digits here, instead of rounding them to 2, we were much better. But even to 2 digits, it's the same number. Next question. A 2.5 kilogram car is traveling 2.5 meters, collides with a stationary cart. There's a spring attached in front of the cart, and the K value is 450. Calculate the maximum compression. So here's what we have here. You got this cart. He's coming across, and he's going to slam into this stationary cart. So this guy's 2.2. And he's going 2.5 meters per second. And this guy's just sitting still, and he's 3.5 kilograms. So my original momentum is all inside that guy. V2 is at 0, so we just have to do that. 2.2 times 2.5 is 5.5 kilogram meters per second. When they collide, there's going to be one instant here where the spring is squished as much as possible, and these guys are basically attached and joining together as one, just traveling along as one, and then they'll push and separate after that. But at that point, it's like an inelastic collision. So P prime would just be both carts moving with one final velocity, and momentum's always conserved. So that's why 5.5 will equal the total mass times V prime. Now we just have to solve for V prime. So 5.5, 2.2 plus 3.5 is total 5.7. Divide that in is... Okay, so that gives me my velocity after the collision. And now we have to find out how much energy went into the spring. I think I drew my pictures way too big here. So let's get EK at the start. The mass 2.2. So 2.5 squared times 0.5, it gives me 6.875 joules of energy. After the fact, all times 1/2. Let's see what we got here. And my velocity was 0.9649. Let's see how much the energy dropped. So we have 0.5, 2.2, 3.5 times, and then 0.9645 squared. It dropped to 2.65 joules. Where'd the energy go? All that energy went into the spring. So let's find the change in kinetic energy. If I subtract those two numbers, I get 4.22 joules is lost, and that all went into EE. Okay, so now we have to solve for this one. The K value is 450. And I gotta solve for X. So we got 4.22, it's already on my calculator screen, times it by 2, divide by 450, and then square root that number, and I get like 13.7 centimeters, 0.13 meters. Okay. On the last page. So we've got a hand grenade, and it's rolling across the floor 2 meters per second, and it's a 1.2 kilogram hand grenade. It's going to blow up, and it's going to break into two pieces. One's going to go that way, one's going to go that way. East, 25 degrees north, and it's 21 meters per second, and it's a 0.8 kilogram chunk. It's going to go off that way, 0.8, then this one must be 0.4 kilograms, and he's going to go down that way somewhere. Okay, so let's figure this out then. Let's do the initial momentum. Initial momentum is just P equals mv, 1.2 times 2 is 2.4. and it's east. So that would be x. That's my total momentum. After the fact, P primed, we're gonna have two pieces, piece 1, piece 2, and they're gonna add up to the same number. Okay, so this will be our mystery one. And we can figure this guy out. Let's take a look at that guy. This will be number 1. He's going off in this direction, 25 degrees, and his momentum is mv, so we got 0.8, and it's going 21 meters per second. That's fast. 16.8. And I got to break that in to the cos and the sine. So 16.8, if I go 25 cos, it's 15.225, so 23. And then we go 16.8, and I got to go 25 sine. It's 7.10. Okay, that's incredibly fast. I think the other piece is going to be actually going back that way. But well, it'll come out of the math. We just need to find the missing numbers there. So what number goes in the box? So this one here in the box will be minus 7.10 to make that add up. And this will also be a negative number. So something take away from 15, so 15.23. I have to subtract 12.83. Okay, so that minus that will give me the original momentum. Okay, things really sped up because of an explosion. It added energy to the system, but the momentum's always conserved. So I just got to put this guy back here in the box. So let's do the big one first, which is backwards and then down. So 12 and 7.1, and this will be P2 primed, the little piece that comes off. We're able to find its momentum. So if I go 12.87, what was 12.83? 12.83 squared, 7.1 squared, add that up, square rooted, we get 14.66 kilogram meters per second, and the direction is mostly west with a little bit of south, and I get the direction 7.1 divided by 12.83, inverse tan, I get 29 degrees. Okay, the question says, find the velocity. I have the momentum, and the mass was 0.4, so I'm gonna have to divide that up, because we know that P equals mv, we have the P, and the mass is 0.4, so velocity will equal 14.66 divided by 0.4, and we get 36.65, and for the final answer, don't forget the direction. Okay, so that's all you have to remember, is the total momentum before will equal the total momentum after, and then find the missing piece. Okay, a 4.5 kilogram block is attached to a spring and stretched to a position 65 centimeters from its rest position. So here's the spring, say this is rest, this guy's stretched out to here. It's 0.65 meters, and then it's released. And it's gonna fly, it's gonna peak its maximum velocity right in the center there. It's be attached to a wall. And we can put the mass in, 4.5. So let's find out the total spring energy here. And the distance is 0.65 squared. So 0.65 squared times 315 times a half is 66.54 joules of energy available. At the middle here, all the elastic energy has been completely changed to kinetic. So EK equals, we have EK, we have the mass of this block. The only thing you're looking for is V squared, or V, so take that, number's still on the screen, times 2, divided by 4.5, square root that, we got 5.4 meters per second. That's it for that question. Last question, it says find the period of oscillation. That's that fancy formula we derived with pi in it. And you got the only part you have to remember is which goes on top, M or K. The heavier the thing, the bigger the time will be. It's slow and sluggish. The heavier the K value, the smaller the time. So M has to be on top. Or just memorize it. Mass is 4.5. K is 315. Let's plug that in the calculator. 2 times pi. 4.5 divided by 315. Square root that. Multiply. 0.75 seconds. That's the end of the practice test.